Good morning, guys, or good afternoon, whenever you're watching this video. I'm sad that you're asynchronous today. Just know that I miss you, and I won't see you next Tuesday because remember, there's no school. We have election day off as a holiday, so don't come to school, don't log into Zoom, and I will see you guys on next Thursday. Okay, so today we're going to talk about solving absolute value inequalities. Before, on Tuesday, we talked about solving absolute value equations. Remember, equations have equal signs. They equal a set value. Inequalities use inequality signs like greater than, less than, greater than or equal to, or less than or equal to. And this has a range of solutions. So it's not just one or two specific solutions, it's multiple solutions. Okay. We're just going to dive right in. So solving absolute value equations and inequalities is very similar. We follow the same steps. The only thing we have to remember is that inequality sign. We have to do a few things with it. So we still want to get absolute value by itself. In this equation, it's already done for us, so we don't have to do it. So now we're going to split it up. So our first inequality is going to be what it gives us, what we can see. X plus 7 is less than or equal to 8. And then just like with our equations before, we changed the 8 to a negative 8, right? We had to do the positive value and the negative value. But remember in last unit, when we solved inequalities, if we multiplied or divided by a negative value, we had to flip the sign. It's kind of a similar concept. So this is now going to be x plus 7 is greater than or equal to negative 8. So we have to flip that. It is very important that we remember to flip that sign, otherwise everything will be thrown off. Okay, so when you make your value over here either positive or negative, the opposite of what you're given, you have to flip that sign. Okay. Now that we've broken it into two inequalities, we can solve for x like we normally would. So we're going to subtract 7 from both sides. And we get x is less than or equal to 1. And then over here, we'll subtract 7 as well. And we get x is greater than or equal to negative 15. Okay. In some cases, you may be able to leave your solution like that. In some cases, it might ask you to graph it. So we're going to graph it on a number line down here. It doesn't matter how you label it. If you're making your own grid, I would just make have a negative 15, a 0, and a 1. You don't need the in-between values. But I'm going to do it for this one. So negative 5, negative 10, negative 15, negative 20. Okay, so that means 1 is going to be about right there. So wherever our values are, we put a circle. Because these are or equal to's, we're going to fill in the circle. They get a closed-in circle. If these were just less than or greater than, they would get an open circle. So it's very similar to when we did inequalities last time. And if they were or equal to, they got a solid line. If they were just greater than or less than, they got a dashed line. It's similar to when we do domain and range. And on the graph, if it's an open circle, it's not included. If it's a closed circle, it's included. Same concept. If these are included, you shade them in. If they're not included, you don't. All right. So now we need to look at this. So if x is less than 1, that means we're going to shade to the left. Okay, because on our number line, as we go toward the left, we're going towards smaller numbers. They're getting negative. Okay, they're decreasing. x is greater than or equal to negative 15, that means we're going to shade to the right. Because as we head to the right, our numbers increase. They get larger, bigger, more positive. Okay? So I know a negative 15, I go to the right, and from 1, I go to the left. So this is bound in between these values. So you're going to shade this in the middle. This shaded purple region is our solution set. Okay? What that means is any of those numbers in that shaded area are a solution. So if I went in here and picked a random number like negative 7.5, if I plugged that into my original inequality, it would work. Okay. Hope that makes sense. Okay, let's go to the next slide. This one's a lot more complex, okay? I gave you an easy one, and now we're gonna do one of the more difficult ones. So we still need to remember our SADMAP, okay, because we want to get the absolute value by itself. Okay, we want to get this alone, just like when we solve equations. So subtraction, addition, division, multiplication, exponents, and parentheses. So first thing we're going to look for is what can I subtract or add from both sides? Well, this is negative 5 times, remember this is multiplication, the absolute value of this minus 6. So I can undo this minus 6 with a plus 6. So I'm going to add 6 to both sides. Negative 5 absolute value of 4 minus 2x is less than negative 60, right? Because negative 60 plus positive 6 is negative 6. Now we're going to look and see what we can multiply or divide to both sides. Because this is times negative 5, we do the opposite, and we divide by negative 5. What important step do we have to do when we multiply or divide by a negative? And this is where I would hope that you would always say, flip the sign, miss. And I'd be like, yes, you're so correct. Good job. Okay, it's very important that we remember to flip that sign if we ever multiply or divide by a negative. If we don't do that, everything will be wrong. Boop. So that gives us absolute value of 4 minus 2x is greater than positive 12. Okay, remember when you divide a negative by a negative, they cancel and they become positive. That's why we have positive 12. Okay, we now have our absolute value by itself, so we can split it up into two inequalities. So we've got 4 minus 2x is greater than 12. We write it how we see it. And then we flip our sign and make it negative. So 4 minus 2x is less than negative 12. Flip. Very important. So it does not matter that we already flipped our sign in the beginning, okay, because we flipped it for a different reason. We were dividing by a negative. We had to. We can flip our sign as many times as required, okay? So now we're solving for x. We want to get x by itself. So we can subtract 4 from both sides, on both of these actually. And we get negative 2x is greater than 8. And negative 2x is less than negative 16. To get x by itself, we need to divide by negative 2. Okay, right now, we should be saying in our head, oh my gosh, I divided by a negative. Gotta flip it. I know that seems repetitive. There's a lot of flipping in this one, but I thought the more we do it, the more you might remember it. Okay. So this means that x is less than -4, and x is now greater than +8. Okay. I'm going to go ahead and make our number line. So I'm just going to make this 0, 2, 4, 6, 8, -2, -4, -6. All right. So since there is no or equal to sign, these get open circles. We're not going to shade them in. They're going to stay open. X is greater than 8. That means we're going to shade to the right, because as we increase, our values are getting greater than. X is less than -4. Our values are going to go to the left. They're going to go less than. Okay, so we're going to shade to the right. This goes on forever, so we can put an arrow. And then it's less than -4. This goes on forever as well, so we're going to put an arrow. And this is our solution set. Okay, so what that means is if we picked a random number, like maybe over here we picked +600. If we plug that in, it would be a solution. Over here, if we picked -125, it would work. It would be a solution. Okay, so your solutions don't always have to overlap. Okay, they don't always have to be in between. You can have solutions like this, because what that means is when we think about our absolute value graph, okay, these are the solutions for this example. If we're thinking about the last example, our solutions were these values in the middle. Okay, so we just have to visualize our graph and think about what these mean. Okay, so you can have either. Hopefully that makes sense, since I wasn't able to answer any questions during that. If you have any questions, just write them down and email me. Okay, there is a little bit of vocab with this that you need to know, and it is and versus or. Okay, so let's go ahead and graph these examples. X is greater than -2 and X is less than 4. You can also write that as this. Most of the time you will see it like this, where it's combined and the X is in the middle. And that's how you read this. So this is -2 is less than X and X is less than 4. Okay. So I'm going to go, I've got 0, 2, 4, 6, -2, -4, -6. All right. At -2, I'm going to have an open circle because it's not included. There's no or equal to. And at 4, I'm going to have an open circle. Okay. X is less than 4, so I shade to the left. X is greater than -2, so I shade to the right. So this is one of those that's in between. Okay. When your solution intervals overlap, that's when you use and, because they're combined. Let's look at our second example. So we've got 0, 1, 2, -1, -2. Okay, these are going to get closed circles at -1 and +1 because they are included. Okay, x is less than -1 goes to the left, x is greater than -1 goes to the right. Okay, so we shade this way forever and this way forever. If they have a gap like this in the middle, that's when you use or. When they're not connected and they're two separate inequalities, that is when you use or. Okay, and this is just an example of a verbal description. So you might be given an inequality and told to solve for it, and then you have to express your answer verbally. Okay, so when we're looking at the and, right, that's the combined one, we could say x is greater than -2 because remember, if the open side is facing the variable, then it's greater than. If the small closed side is facing the variable, it's less than. So x is less than 4, and x is less than 4. If you have the separate ones, you will have that word or in there, okay? So x is less than or equal to, guys, if you have that or equal to sign, you have to describe the or equal to. If you forget to say that, it's wrong, okay? To -1 or x is greater than or equal to +1. Okay. You now have, oh wait, my delta math is, hold on 1 second. I need to pull up the delta math so you guys can look at it. I'm going to show y'all an example of how to enter the answers. View, no, not view. Okay, it's called solving absolute value inequalities. Okay, so this is where you'll go, your absolute value inequalities. You'll solve it down here in the keypad. It gives you these little buttons, the less than, greater than, or equal to. If you have a solution that's an and solution, it wants you to type them as the combined one with the x in the middle. If you have an or, it has a little or button that you can press so you don't have to type it, okay? So please complete this today. If you don't at least start it or work on it, then I have no way of counting you present attendance-wise. So at least start working on it. If you have any questions, just email me. Okay, and I'll see y'all next week. I hope you have an awesome day. Bye.